Hello everybody, my name is Hadrien Croubois and I'll be presenting you a few Solidity tricks that you might consider useful during your hackathons or that might just interest you as part of the latest development of the ecosystem. Again, my name is Hadrien Croubois. I'm a research engineer, smart contract developer, and protocol designer at iExec. I've been in this ecosystem for almost 3 years now, and I've been doing many contributions to the community, including Kitsune Wallet, TNS Login, NF Wallets, and many other contributions that you might have seen at previous hackathons. Here are some social media links that you might find useful if you want to contact me. So about iExec. iExec is a marketplace for decentralized off-chain computation. This means that it's a place on the decentralized web where providers of computing resources can meet people that need to access these computing resources. And they can use a blockchain and micropayment using ERC20 tokens to settle transactions and perform computations. This is also useful for cloud users that would otherwise go to AWS or other platforms, but it can also be leveraged by smart contracts. This means that using the iExec platform, your DApp can access computing resources that are inaccessible to otherwise blockchain computations. For example, you can use GPU and other kind of computing resources that to perform operation that cannot be done just inside the VM, the Ethereum virtual machine. So this can be very useful, and you can also process secure data, something that smart contracts cannot do. There are many use cases, and I encourage you to go through our website to check out all those use cases. So version 5 of iExec. Why do we need a new version 5? Basically, the protocol has been ready since version 3, and there has not been any smart contract update from version 3 to version 4. However, we felt that with this new release, we needed to push things further and improve the composability of our application and make it proof. Basically, the idea is for V5 to be basically the latest version of iExec, so that all further developments are improvement of this version 5, but with no major gap in the system. And so I will address a few of the concerns that we had to deal with when building this version 5 and how we address them. And I think that all these elements can be useful to other people in the ecosystem, other application developer and hackers as part of this Wyoming hackathon. So the first question we had to address was address predictability that we addressed with Create 2. And basically the question we asked that was, what is the address of our smart contract on such and such blockchain? And at iExec, we are present on many blockchains, mainnet obviously, and Goerli for testing purposes, but we also have our own sidechains that we use to have better scalability and lower gas prices. And the question is always, what's the address of this contract on this blockchain? And this is always painful because if you send transaction to the address of a contract on another blockchain, then the transaction will fail. And so the question was, how can we make that better? And one of the ways to make that better is to make sure that whichever blockchain you are on, the address are always the same. And so you can learn about Create 2 on this video that's on YouTube. I will not play it here today, I'm sorry, but it will be available with the slides. So you will be able to have a look at it if you want to learn more about the details of Create 2 and how I use it. So this is a video from DevCon a year ago, but it's still interesting to learn about that today, and it will be a complementary. So if you clearly are on the DevCon track, you should check it out. So what are the advantages of Create 2? Well, the advantages of Create 2 is that by creating new smart contracts using this opcode, you can deploy new assets and know their address in advance. For example, you can predict the address of a user's wallet before it's even deployed. And this provides interesting use cases where you can ask someone to put funds on its address, on the address of its wallet, before the wallet is even deployed. This means that you don't have to commit to pay high gas fees to deploy a wallet until it's really meaningful to do so. So this is a use case that has been exploited by Unilogin, but many other people could use that in this ecosystem. Also, it helps avoid confusion between blockchains. For example, we are moving some part of our application right now from mainnet to XDAI, for example, because of scalability issues on mainnet. And most of the time, the addresses are different on the different networks, and this can lead to bad transactions, to lost funds. So the idea is that using Create2 and using a Create2 factory, you can make sure to deploy your app at the same address on all networks. This is something that I discussed last year at DevCon. So I encourage having a look at my past contribution if you want to know more about that, or if you want to access the Create2 factory that I already deployed on most tests and live networks. And our last use case that is pretty interesting, but that hasn't been exploited yet and that's been considered very dangerous by the community, but I think it can be done in the right way, is to be able to redeploy smart contract after they have been self-destructed, which is something that can only be done if the contract has been created using Create2. And so these provide use cases like deploying a contract, initializing it, working with it, and at some point destroying it with self-destruct, and redeploying it to the same address, potentially with a different bytecode. So this can be very dangerous if people have expectation that a contract bytecode will not change through time. But it also can be very useful for upgradability purposes. So it's something you might want to consider. So as always, I will put some piece of code so that you have a better idea if you are that developer. The first line of code you can see is the way to deploy a smart contract using the standard create in Solidity 0.6. And just the line below that is how you do it using Create2. And you see the only difference is that it uses a salt. So the salt is a way to distinguish between different creation of the same bytecode by the same address. Otherwise, they would end up at the same location, which would be an issue. Also, I've included, just for the sake of completeness, how you can do it using OpenZeppelin's Create2 library, which can also be very useful, in particular if you don't have the contract as a Solidity object in your code, but if you pass it, for example, through construction or through argument, here you can see that I've just put the creation code using the trick using types mycontract.creation code, but you could also use that to deploy arbitrary contracts that have been provided as in the call data, which is what the factory does. And again, you will be able to have an access to the slide after this talk. So I've put the link to the factory that I've deployed on most network that I've told you about, that uses this trick to be able to deploy any contract arbitrarily on any network, but in a predictable way, so that you can deploy it to the same address, both on Goerli, XDAI, mainnet, Ropsten, Ringbee, any network, basically. So the second trick I'd like to discuss, it's not really a trick, it's more of a trend in this ecosystem. It's NFTs, more likely ERC-721. And I think this trick with ERC-721 comes from the fact that we had to index some assets in the iExec platform, namely application, dataset, and worker pool. And there was always this question of how many app owners are there, or how many apps do each owner have? And of course, we have mechanisms through the blockchain auditability to access this information, but it was not very easy to access, and it was not compatible with other applications out there. And this is where NFTs come in. And basically, why use NFT? Basically, you should go beyond the just collectible aspect of NFTs. NFTs are just a ways to represent a family of assets that needs to be indexed. So if you have many similar entities that are owned and might be transferable, it can make sense to consider NFTs to represent them. And there might be anything. For example, at iExec, we turned smart contract addresses into NFTs. Our mechanism just say that you deploy a smart contract, you get an address using Create2, and you consider this address to be the token ID of an NFT. And that way you can do many tricks, like the smart contract can be aware of the NFT registry and know who its owner is, but still you abide by the ERC-721 standard, which means that your asset, your exec asset in version 5 are visible in OpenSea, in Etherscan, and you might know that you might put them in some rockets just to take a loan, a crypto loan, using your NFT as collateral. This is something that Rocket does. Depending on your NFT might be valuable or not, so you might use it as collateral. And at iExec, we believe that putting data, particularly private data, into NFTs, which is what we do with iExec datasets, and being able to transfer the ownership of this piece of data, this has value. So this can be used into the DeFi ecosystem. And I think this will be much more meaningful in the long run to have valuable pieces of data be considered as NFTs instead of just CryptoKitties. I mean, CryptoKitties are nice, but we need to move further than that. And so if any application you design contains a family of assets that contain ownership information, you should really present them as NFTs. So this is an example of a smart contract from my exec, just for sake of clarity. And if you want to have NFTs in your smart contract, don't reinvent the wheel. Don't rewrite the ERC 721 contract. OpenZeppelin does that already. So you just have to inherit from the OpenZeppelin version and use the mint mechanism, which is an internal function whenever you want to represent an asset as an NFT. And here you can see that there is a line where we use create2 to create a new entry, which is basically a proxy in this case. And down the line, what we do is we just mint this token, and a token that represents this entry by just casting the address to a uint 256. And this means that there is a dual representation of both a smart contract and an NFT. And this is very powerful in the iExec platform. So this is some nice trick, I think, that uses very basic solidity concept, but in a way that is, I think, very interesting. Another mechanism that we worked on a lot for version 5 is proxy. And this dates back from almost version 3. I mean, we considered putting it inside version 4, but as there was no smart contract upgrade, we postponed it until version 5 until we were completely ready. The thing is, proxies are very nice, and delegate code is very nice if you have the right governance, because it opens a lot of possibilities. And one of the questions we were facing was, what are we going to do with this protocol after V5? Are we going to create a V6, a V7, a V8? What are we going to do with the smart contract? Are we going to need to redeploy them with any new version anytime we want to alter the protocol or put in new features? And this is not nice. First of all, it's not nice because it has a cost, but it's also not nice to our users because since our smart contracts are trustless, there is no way for us to access the fund of our users. So if we want to create a new version, our users have to manually intervene, remove the fund from the previous version, and put it in the new one. And they need to redeploy the application, redeploy the dataset, and stuff might get lost behind. For example, reputation score, past activity history. And if we want to create invoices, for example, for the activity on iExec, then we have two platforms that we have to manage at the same time, and it becomes a mess. So the question is, how can we do better than that? And this is a feature that is just 2 months old in this ecosystem, but we already used in our latest upgrade from just a few days ago that you might have heard about. And so the question is, why use proxy? There are many reasons why you might use proxies. First one is plain and simple upgradability. You are working on a project, there are smart contracts, there might be bugs in the smart contract. And if you want to fix them, then there is a way to just replace the previous logic with the new logic while keeping all the data. And this is done through delegate calls. Delegate call just applies the logic from another contract using the data from the caller. This is very powerful. However, it's also very dangerous, and you need to think about the governance of your application. So using proxies is not a big deal if you are, I mean, I think it's even a very good thing if you are just prototyping and doing like small projects and hacks. However, if you want to turn into production, you need to be very careful about all the power that the owner, the person that controls the upgrade can do. So this is where you might implement time locks, multisigs, or DAO as controller of your smart contract. A second aspect where proxies are interesting is with modularity. This is what we do at iExec for version 5. We've got just much further than plain and simple upgradability. Using ERC 1538, also known as the Diamond Standard. I mean, Diamond Standard is just a small rebranding and renaming of 1538. You are able to select which code to use depending on the message signature, on the call signature. And this is very powerful to build modular application. We will see later in this talk. And if you want to build big application and you are limited by the upper boundary on smart contract size and gas, this is a good way to build more modular application on the blockchain. And I think it's really underrated. So definitely check it out. And the last reason where you want to use proxy is gas efficiency. If you want to deploy the same contract many times over and over again, then it makes sense to just deploy it once, to have the logic on chain, and just create simple proxies. This is what most wallet providers do. For example, Argent's doing that, and it's very interesting. This can be done with upgradability in mind, or even without upgradability. We do that at iExec, where we deployed some proxies at some point that cannot be upgraded. It's just that it's much cheaper to do so. So it's cheaper to create, for example, an application or dataset in iExec just because the representation doesn't need to contain the entire logic. You just create a small proxy, as we saw before, and just put that into an NFT. And so this is the same example as I told you previously with NFTs, exactly the same piece of code. But here we will we'll focus on other lines. You see that what's created using create2 is a proxy code. Proxy code is defined much higher in the code in the real implementation. And you see that once the proxy code is deployed, then we cast it to an initializable upgradability proxy. So this is an Open Zeppelin proxy, and just we call the initialize function, and we set the master and the arguments. And so this is basically a way for our registry to have the address of a single master that is deployed at construction. And then whenever someone calls the min create function through redirection, because obviously it's internal, then it will create an entry, and the entry will be initialized with arguments that are formatted by the caller. So if you want to have a more detailed look at that, you can have a look at the iExec code. Again, the link will be at the end. Also, I was discussing the ERC 1538. So here is a virtual representation of iExec smart contracts right now. And basically the white circle in the middle that is transparent on the slide is basically the proxy. And you've got two circles around that. The inner one is basically the address of all the modules that are used by iExec right now. And the outer circle is basically all the functions that are attached to each module. And you can see that on this gray module that starts in 0561, there is a deposit ETH method included in that. And so this is very powerful, as I said, because it allows us to manage our smart contract in a modular way. And obviously we want it to be auditable. So there is monitoring tool and implementation that are available out there. If you want to try it out, it uses the graph. I think it's awesome. Another trick I want to discuss is signature verification. And again, it's not really a trick. It's something that is pretty standard. But the question was always, how do we make our application compatible with whatever wallets people are using, including Argent and Gnosis? And so the question is that most of the time, people just do signature using their Ethereum wallet, which is an elliptic curve that is pretty standard. And you use this elliptic curve to sign transaction. And you can also use it to sign message and even to sign type data with ERC712, something that we used in the version 5. And it can be checked on-chain using EC Recover, and it's very nice because it's used for state channel, data transaction, anything. Like the DAI permit function uses that. It blew up a lot. I mean, people think it's amazing, but it's had use cases before that. And it's going to be everywhere, in particular because gas prices are very expensive, and rather than writing some state to the blockchain and having someone verify, it's much easier to give them a signature that you agree with that so that they can bring the signature later, which is the whole logic of state channel. And the issue is that if your address as a user is a smart contract, for example, because it's a wallet, an Argent wallet or a Gnosis wallet, then this smart contract doesn't have a private key. So you cannot sign with your smart contract. You can sign with the owner of the smart contract, but then the application doesn't know how to check that. And this is where signature verification, delegated signature verification comes in. And it's very important if you want to check state channel off-chain messages in your application that you consider that the sender might be a smart contract. And in this case, the code is pretty simple. It's rather than just doing the EC recover, what you should do is, first of all, verify is the sender is a smart contract. And if the sender is a smart contract, then you should try to call ERC 54 on this address and provide it the hash that you're trying to verify and the signature. And the smart contract will tell you whether it verifies this signature or not. If it doesn't verify it, then you should catch that using the try-catch method that's available in 386. It's very nice. And if this is not a smart contract, then just fall back to the traditional EC recover. But having this, if it's a contract, do ERC 1654 will open your application to a lot more users. And I think this is great. This is very important that in Ethereum, in Solidity, we design our application or dApps so that many people can interact with them. So a small bonus round with additional tricks that I didn't want to discuss a lot, but that I think are still useful. I think this is, first of all, the short signature one. So we discussed EC recover just before. There is a trick for your signature to be 64 bits long and not 65 bit long. This is detailed in the IP 2098. So you might have a look at it, and it's very simple to support both formats of signature at the same time. So it will make your application future-proof, so that if at some point short signature becomes a de facto standard, then your smart contract will have the ability to process them. Also, it's more gas efficient since there is less call data to send when you send a smaller signature. There is a call with limited gas. So this has been a discussion a lot in the meta transaction ecosystem. I mean, we discussed that with MetaMask and with many people on Twitter. And you should be aware that if you do an arbitrary call using the gas directive, this is best effort. If there is not enough gas available at that part of the execution, then it will not revert. It will just continue with the smaller amount of gas. And if you want to make sure that your call will at least have the amount of gas that you specified. I mean, not at least exactly, because it cannot be more than that, but it could be less. So if you want to make sure to do that, just put the assert that I've included in this piece of code. This is very interesting because it makes sure that if the call reverted because it's an out of gas, then you can verify that after the fact that the right amount of gas was in fact provided. So yeah, that's all the tricks and the solidity features I wanted to present today. Something that we use in iExec Poco v5 that I will continue using in all my other projects and that you might be interested in. So first of all, what I want to say is that by building v5, it's not that I learned this kind of stuff. I already knew it, but it became obvious that all those small tricks are pretty simple and can seem stupid, but when you put them together, it becomes very powerful. And the thing is, it's always better to assemble those small bricks and to build a big project using small bricks than just starting from scratch. So don't start by rewriting code that has already been written by everybody, like use OpenZeppelin's contract, and just try to think how you can assemble a small, simple element in creative way. And you should focus on composability. Composability of the blockchain ecosystem is amazing. I mean, the fact that we can build a compound and array on top of DAI, that we can build Uniswap on top of ERC20. This is amazing. If you build your project in a way that is specific to you, your project will work, but nobody will be able to interact with it, or it will be very difficult. But if you use very common standards, like transforming assets that should not be NFTs into NFTs because it makes sense and it's creative, then you open your application to interacting with other applications, and this will bring value to the other application that can benefit from you, but also to you that can benefit from the other application. And if you go have a look at the token the ecosystem in the blockchain right now in Ethereum, the most valuable applications, the most valuable dApps and tokens are those that can interact with one another. The fact that Aave, Compound, Uniswap, DAI can all interact with one another. This is very powerful, and you should try to be part of this construction. You can put yourself on top of this construction, which is easy because you master whatever is under you, but you should always consider that people might want to build on top of you. And this should be one of your priorities. Just after building secure application. Never compromise security. So again, I hope you will have access to the slide. I've put a few links that might be useful to you. First one is my latest article on the exec Medium, which is about what we just discussed and future-proofing exec. So if you want to learn more about the philosophy behind this smart contract update, you can read it here. And then I've put sources of code. So OpenZeppelin contracts, obviously, that should be your go-to repository whenever you want to build smart contracts application. iExec Solidity, which is my own extension of OpenZeppelin contract that includes a few pieces of code that are not in OpenZeppelin that you might consider useful. And last but not least, the iExec Poco, so with the version 5 in it, which I think could be very interesting to smart contract developers because all these tricks are applied in, I think, what is very creative and meaningful ways. So it's always a good point to start learning about what can be done in this ecosystem. So thank you very much. That's all from me today. I would have loved to answer a few questions, but obviously I cannot since I'm in a completely different time zone. I hope I will be able to meet hackers and other participants of this conference in future events that will hopefully start happening again face to face. And obviously, I'm very looking forward to all the hackers' contributions. So I'm sure you will come up with great ideas. I'm very impatient to joining them. And I think many great applications will come out of this amazing Wyoming hackathon. Thank you.